Hello everyone, welcome to Maths IEC. Today we are going to discuss about a proper comparison between series and parallel circuits. Now many people have a quite good idea about these things, especially if you are a physics student, but we are just going to look at all different aspects of a comparison between these two type of circuits. Now the easiest way to understand a series circuit from a parallel circuit is that a series circuit has components that are next to each other. So components are placed one after the other. So you can see in this one we have the path like that, and then we have the resistor, then you have a bulb, then you have the next resistor, and like that. Whereas in a parallel circuit they are more side by side on different branches. That is the first difference. Now the next two differences are kind of connected. There is only one path for the current to flow, therefore the current through each component is the same. Now let's assume the current through this one is 2 amps. So 2 amps will go through this one, this one, this one, this one. So everywhere in the circuit you have the same current. Very straightforward. However, in a parallel circuit, let's say the current coming out from here is 5 amps. Now this 5 amps comes to this junction, and then now it will split. Now how much of this current goes to this really depends on the resistance of this path and this path, but let's assume this is 1 amp in this example. Now 5 take away 1, the remaining 4 amps will go down this route. Now let's say out of this 4, 3 amps go that route. Then the remaining 1 amp, 4 take away 3, 1 will go this way. Now that 1 amp will come here. This 3 amp come together here. 3 add 1 in this branch we have 4 amps. We have this 1 amp coming here. 4 add 1 is 5 amps. Now you can clearly see the current that left the power supply is 5 amps. The current that's coming through is exactly 5 amps. So we know this the way we mark the current is correct. So the current split up, you can see there are multiple values, 1 here, 3 here, a different one here, all that. But in a series circuit, everywhere is the same, just 2, 2, 2, 2, 2, 2, and it's the same. Now the next difference is from voltage. So the voltage here in this first example is 10 volts. Now that 10 will split between these three, let's say 5 volts, 2 volts and 3 volts. So they should add up to 10 because there is no internal resistance. How they split really depends on the resistance, but the idea is the voltage splits up. Now in a parallel circuit, you got 8 volts here, you have 8 volts across this, 8 volts across this, and 8 volts across this. So the voltage does not split up in a parallel circuit. Now it's very obvious that voltage can split up in the series one, but sometimes students kind of get confused. They just memorize, okay, in a parallel circuit it does not split up. Sometimes they don't really exactly understand why. Let me just explain it in a very simple practical way. Imagine there is a battery. Now if this is a 3 volt battery, and if you connect one bulb like that, obviously this bulb feels the full 3 volts, right? Now what if you connect another one like that? Now that also gets the same 3 volts, isn't it? So these two are in parallel and they both have the same potential difference. Whereas in a series circuit, let's say this is a battery with 3 volts, you connect this and that. Now 3 volts is across both of them, so the voltage has to split. Now the next difference is that in a series circuit, if a fault develops in one component, all others will not work. Now let's say this bulb breaks, something happens. Now you can clearly see there is a gap in the circuit. So when there is a gap, current cannot pass through. So what will happen? None of the other components will work, so everything will break. However, Imagine in the parallel circuit, let's say this one again got damaged. Now, no current can go through that branch, but current can still go through like that. Current can still go in this branch. So others are still intact. So if a fault develops in one component, others will still work. So parallel circuits are versatile in that sense. Now the next point is about controlling these components. Now let's say in a series circuit, if you put a switch here, when that switch is off, all of these things are not working. If you close the switch, all of them will start to work together. So all components are controlled by one switch together. Whereas in a parallel circuit, the situation is different. Now, if you put a switch here near the power supply, like before, if you turn it off, nothing is working. If it's on, everything will work. Now also, you have the option of putting a switch here. Now if you put a switch here, now that does not affect the other two, it only controls what's on that branch. Similarly, you can add a switch here. Now if you put a switch here, that only controls the bulb. So if you want, you can add a switch here. Now that will control only that resistor. Also, you can add a switch somewhere here. So what will happen now? When this switch is open, these two, the bulb and the resistor, aren't working. When this one is closed, they will start to work. But the top resistor will work irrespective of whether that switch is on or off. So in a parallel circuit, you have more aspects when it comes to control it. So here you go. These are the basic differences between a series and a parallel circuit.